Morning students, today I am going to teach you number system. Morning students, today I am going to teach you chapter number system. In this session I will cover decimal number system, binary number system, octal number system and hexadecimal number system. First, I would like to discuss about decimal number system, taken from Greek word dec, which means 10. Why 10? Because it has 10 digits from 0 to 9. 10 is called the base of decimal number system. Example, 170, 29, 543 are all decimal numbers. In decimal number system, number can be written as, first I will take number 1. We can write 1 into 10 raised to the power 0. So how will you write this? 10 raised to the power 0 will be 1. 1 is here. 1 into 1 will be 1. Again, now next number is 17. 17, I will write 17 like this. This is your ones and this is your tens. So here I will write, we will start from 0. 7 into 10 raised to the power 0 and 1 into 10 raised to the power 1. So here 7 into 10 raised to the power 0 will be 7, because 10 raised to the power value will be 1. So here, how will I display 543 in decimal number system? What is the place value of 3? 1. Place value of 4 will be 10. Place value of 5 will be 100. So here I will write 10 raised to the power 0, okay, and 10 raised to the power 1 and 10 raised to the power 2, because the value of 5 means place value of 5 is 100. That is why we have to write here 10 raised to the power 2. So what is the value of 10 raised to the power 2? 100. 100 into 5 will be 500, and 10 raised to the power 1 means 10. 10 into 4 will be 40, and 10 raised to the power 0 value will be 1 into 3. Here will be 3. So 500 plus 40 plus 3. Okay. What will be the answer? 543. Now I will discuss about binary number system. What is binary number system? Bi means 2. So 2 is the base and only 2 digits 0 and 1. Example 0, 1, 1, 1, 1, 0, etc. Then octal number system. Oct means 8. So 8 is the base and have 8 digits from 0 to 7. Example 34, 12, 56. It looks like a decimal number system, but it is octal number system. Next, hexadecimal number system. Hexa means 16. So 16 is the base and there are 16 digits from 0 to 15. But after 9, that is 10 is written as A and 11 is written as B. 12 is written as C. 13 is written as D. 14 is written as E. 15 is written as F. Example 9F, 14B, 147A, etc. Now I will discuss about addition of binary numbers. Before we start this topic, first I would like to tell you why binary. Because computer only understand binary data in the form of 1 and 0. It has several switches, work on the logic of current flowing or not flowing. In fact, every electronic device works on the logic of on and off. On means 1, off means 0. Computer is also an electronic machine, so it also work on the logic of on and off. In computer, on means 1 and off means 0. So, binary number system is used for computers. Now, we will see how I can add binary numbers. Now, we will learn how can we add two binary numbers. Here, I have written 1110. I will add two binary numbers. 1 plus 0 will be 1 and 1 plus 1 will be 1, 0 means 2. How? This is not decimal number. This is binary number. Okay. So we will convert this binary number into decimal number. First, I am converting this binary number. This will be raised to the power 0 and this will be raised to the power 1. So, this is binary number. That is why I am taking here 2 raised to the power 0, 1 into 2 raised to the power 0 plus here 2 raised to the power 1. Okay. Why I am taking here 1? Because this is place, its place value is 10. That is why I have written here 2 raised to the power 1. So 1 into 2 raised to the power 1 will be 2 and 1 into 2 raised to the power 0 will be 1. So addition will be 3. Likewise, here 1 into 2 raised to the power 1 plus 0 into 2 raised to the power 0. Addition will be 2 plus 0 means 2. So, whole addition will be 3 plus 2 will be 5. I have converted this binary number into decimal number. You can see here raised to the power 0, raised to the power 1 and raised to the power 2. Okay. So 1 into 2 raised to the power 0 will be 1 and 0 into 2 raised to the power 1 will be 0. Why? Because the value of here the value of 2 is equal to 2, but it will multiply with 0. That is why the value will be 0. Now next is 2 raised to the power 2 means 4. 4 plus 0 plus 1 will be 5. Okay. So when we convert this binary number into decimal number, we will get number 3. Here 2. Addition will be After addition, you will get 5. Okay.
In this lesson, we're going to talk about how to add binary numbers. So let's start with the basics. What's 0 plus 0? 0 plus 0 is 0. Now what about 1 plus 0? How can we add those two binary numbers? 1 plus 0 is 1. Now there's some other basic rules to go over. What about 1 plus 1? In this case, we need to carry over. 1 plus 1 is going to be 0, but you need to carry over a 1. And so you get 1, 0. So basically, 1, 0 has the decimal equivalent of 2. Now what if you have 3 1s? How can you add this? In this case, it's going to be 1, and you carry over a 1. Let's write that here. And so you get 1, 1. So if you have 3 1s in a single column, it's going to produce an output of 1, 1. Now let's work on some example problems. Go ahead and add these two binary numbers. 1010 plus 1001. Now the first thing you should do is you should line up these numbers. And then add up the numbers column by column. So here we have 0 plus 1, which is 1. In the next column we have 1 plus 0, which is also 1. And then for the third column, 0 plus 1, that's 0 plus 0 rather, which is 0. And then for the last one, it's 1 plus 1, which is going to be, based on the last two examples, 0, but you need to carry over a 1, so you get 1, 0. Now, to check the work, let's convert each binary number into a decimal number. So let's separate this into columns. So this is 1, 2, 4, 8, and 16. So 1010 is going to have the decimal equivalent of, this is going to be 8 plus 2 because it's in this column. 8 plus 2 is 10. So that's the decimal equivalent of 1010. Here we have an 8 and a 1. So 8 plus 1 is 9. 10 plus 9 is 19. So here we have a 16 plus a 2 plus a 1. So that adds up to 19. And so we can see that we have the right answer. So this is our answer right here. So that's how you can add two binary numbers. Now let's go ahead and try another example. Go ahead and add these two binary numbers. Feel free to pause the video if you want to try this example. So let's start with the column on the right side. 0 plus 1 is going to be 1. And then in the next column we have 1 plus 0, which is 1. And then it's 1 plus 1, which is going to be a 0, but we need to carry over a 1. Now for the fourth column, it's 1 plus 0 plus 0, which will equal 1. And then we have 0 plus 1, which is 1. And then next is 1 plus 1, which is 0, but carry over a 1 to the next column, which will give us 1. So now let's confirm our answer. But let's separate everything into columns, just like we did before. So this is going to be 1, 2, 4, 8, 16, 32, and 64. So let's get the decimal equivalent of the first number. So we have a 32 plus a 4 plus a 2. 32 plus 4 is 36, plus 2, that's 38. And then for the next one, we have a 32 plus 16, which is 48. 48 plus 4 is 52, plus 1, that's going to be 53. Now 8 plus 3 is 11, carry over the 1. 5 plus 3 is 8, plus 1, that's 9. So this should equal 91. So we have a 64 plus 16, so that's 80, plus 8, that's 88, plus 2 is 90, plus 1, 91. So we can see that we do indeed get the right answer. And so now you know how to add binary numbers. As you can see, it's not very difficult as long as you follow the process. So make sure you remember these two things. When adding 1 plus 1, you're going to get a 0, but you need to carry over a 1 to the next column. And so the end result is that you get 1, 0. And if you're adding 3 ones together, it's going to be 1, but you carry over another 1. And so instead of getting 1, 0, you get 1, 1. And if you remember these two things, you can easily add two binary numbers together. For the sake of practice, let's work on another example. So go ahead and add these numbers. So feel free to take a minute, pause the video, and work on this example problem. So let's start from the first column on the right side and work our way towards the left. 1 plus 1, we know that it's going to give us 0, but we need to carry over a 1 to the next column. 1 plus 0 is going to be 1. And then in the third column, we have 1 plus 1, which is 0, but we got to carry over a 1. Now for the fourth column, we have 3 ones. Do you remember what we need to do if we encounter this situation? If you have 3 ones in a single column, it's going to give you a 1 for that column, but you need to carry over another 1 to the next column. And so 1 plus 0 plus 1, we could ignore the 0, and so it's the same as 1 plus 1, which will give us a 0 for that column, but we got to carry over a 1. And for the last column, we have 3 ones again, so it's going to produce a 1 for that column, but we need to carry over another 1 for the next column. So 1 plus nothing is going to give us 1. And so this here is our final answer. But as always, let's confirm it. So let's begin by drawing lines to separate the columns from each other. And then let's write the powers of 2. 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth is 32, and 2 to the sixth is 64. So let's convert the first binary number into its decimal equivalent. So we have a 32 plus 8. 32 plus 8 is 40, plus 4, that's 44, plus 1, so that's a total of 45. Next, we have a 1 for the 32 columns, that's 32, plus a 1 for the 16 column, so 32 plus 16, that's 48, plus 8, that's 56, plus 4, that's 60, plus 1, and so that's going to be 61. Now 1 plus 5 is 6, 4 plus 6 is 10. So we get 106. Now we have a 64 plus a 32, so that's 96. 96 plus 8 is 104. 104 plus 2 is 106. And so our answer is indeed correct. So this is the final answer right here. 1101010. And so now you know how to add binary numbers. As you can see, it's not very difficult, and it's pretty straightforward. So feel free to check out my next video on subtracting binary numbers.